next what I have is some kind of testing. Uh, Testing, if I'll show you uh, the today's topic, right, is
Mm-hmm.
is kind of testing the code. If you are writing some kind of NumPy code, and if you want to test it, then how would we do that? Indexing and functions. So these 4 posts I prepared today, and these are basically, testing is something which people take for granted a lot of times because developers don't test. But if you are working in test driven development with methodology, then you have to make sure that you know how to write test suits and work with them. So this is basically a lot about this is about doc test, which is simple. This is a bit tricky, unit test. And before that, we covered indexing yesterday. We left out indexing and functions and NumPy. These are very, uh, how should I say? This is basic, right? You were aware of how the indexing happens, 0, 0, 0, 1. First rows
Mm-hmm.
will be picked. So this is obvious to you.
Mm-hmm.
Then this is slicing in NumPy. If you give something like this, starting this, if it is left out, then this means starting, and if it is left out here, it means till the end. So starting till the second, exception except exclusive of 2. So still 1, 0, 1 over here, and 1, 0, starting from 1 till the end, starting till 1 start and 1 starting from 1 till end. Its shape, it's 2 by 2. So this is the kind of slicing you can use, slicing expressions. I wrote some code for Boolean type of indexing as well. Let's say we have an array like this, 2-dimensional array, 1 2 3 4 5 6 NP array. Then if we give B some kind of, over here we specify a list of elements that we want. So Boolean also, we can say, let's say we only want first element and we don't want the rest, then we would do false, false, and first element will be picked. So this is another type of indexing that we can work with using NumPy. And I was reading a book. If you want, right, you were asking for structure. So when you talk of NumPy, it has got a lot of applications, but at times as a machine learning practitioner, you need to just become familiar with the basics and not get into deep dive into the NumPy, everything that NumPy has to do. So this is a book on NumPy and this is a book on pandas. Now, if we, like you were saying that you want to do something in pandas as well. So if that is the case, then I prepared something for to take you through these uh, these whatever chapters these are, and it has a chapter on NumPy as well. And according to this chapter, there isn't a lot that you need to know. Most of what we have covered is should help you. Linear algebra, right? We used this package yesterday in computing the norm, if you remember.
Mm-hmm.
So, and then matrix dot, this we used, dot product we used yesterday. So
Mm-hmm.
commonly used NumPy, 1 second. I think I can take a picture of this as well. Paint. So as a data scientist, if you want more on NumPy, then let me know. Otherwise, this would be the roughly the last session on NumPy, and then we would proceed with pandas. And once pandas is done, we'd proceed with machine learning algorithms like naive Bayes, linear regression, logistic regression, decision trees, which would take couple of sessions till we are exhausted of commonly used machine learning algorithms. That is the kind of structure I have for to present to you right now. Is that okay? So that we don't waste time in very going in depth in the NumPy and all that. So pandas.
My aim is not towards the algorithms, ML algorithms, because I have already good knowledge on the algorithms.
Okay. Okay. So if that is the case, then which part? So these are basically kind of, you should remember that when you are dealing with matrices, you might have
I want to cover all the functions which NumPy covers and pandas.
all the functions.
Yeah, functions NumPy. Yeah.
So this is not exhaustive list. If I would have to open the documentation for NumPy and pandas, this book specifically is for pandas. But if you want to like NumPy, I shall show you what kind of work we can do.
NumPy, pandas, both need to work on.
Okay. So maybe I can like
the regression, yeah, expressions.
this is
Regular expression, no? Regex the
regex. If you want to do regex, that is part of Python. If you want, I can take you through that also. Just a second. And
so see, I want to cover whole Python.
Okay, whole of Python.
Which we generally use, no, in day-to-day coding. That I want to cover.
So this much is clear, right? That indexing is done like this, and the functions, list of functions is like you have some kind of unary functions, log, exponential, square root, CL, floor. But then test cases.
So NumPy is more towards the arithmetic, correct?
Yeah, NumPy is more towards arithmetic and doing the mathematics. If you have ever if you are ever
mathematical calculations.
Yes, mathematical calculations. So for that, it would like need to know basis. If we leave NumPy for future, that we'll pick up NumPy again on need to know basis. Like right now, we don't need to exactly remember and memorize all of these functions. A slight understanding should be enough. And we have covered how indexing happens. We have covered yesterday some functions, this factorial, right? We covered yesterday. Now, this post is about testing it. You're seeing this piece of code. It wasn't present yesterday, I believe. So how do we test the code? This is from core Python, and its application has been, it's like mix of Python and NumPy, because doc test is a Python package and NumPy is a Python package. Now we're using them together. So basically you're getting a taste of both NumPy and Python. Now, when we say, shall I explain this post, these two posts, which are you giving you a idea of
doc post,
testing, doc test here. So
yeah.
If you have like a factorial function, we were able to see that this kind of expression would give us the, but what about testing? Do we always have to assert, kind of write lines like we are doing over here? It is automating the testing. If we want to say let factorial of 3 is 6, then we can call this function, get the output in a variable and check its value, whether factorial equals to 3. But does that but what about automating it? We can write this kind of thing in code also, but when we write it in the form of test case, we can simply call the doc test dot test mode, and it will call our it will do what it will do. It will execute this statement and expect this to come. Now, if we say factorial 0, then
And test mode is an inbuilt function.
test word this.
Test mod mode.
Okay,
Test
yeah,
mode.
this is a function with the test mode means that we are trying to run the test cases along with the, if we don't use this statement, we can simply call factorial, and that will ignore this part of the function. It won't be called. Got it? This is for testing. This is our test cases.
So we have defined
2 test cases over here. Yes, you're right. One is that when we say factorial 3, we should get 6, and when we say factorial 0, we should get it should raise an error, because 1 comma 1, right? It will try to do cumulative product, and then there is nothing to find product of except for so 1 to 1 will give an empty
this
array,
is
I
how
believe.
we do the testing generally.
How we do the testing?
This is how we do the testing.
There are 2
Or
ways discussed over here. If you refer to the book, right? 1 second. It's in chapter 8 of this NumPy book. Chapter 8. Chapter 6. Profiling and debugging. Chapter 7. Testing with docstrings. This is what you're seeing. This entire chapter is on testing the code, well, quality assurance in this book, NumPy cookbook. I can share this book with you. And most of this have been these 2 examples have been taken from these over here. PyFlakes is important in the sense that it helps you with unused imports and used variables, but I did not cover that because well, we are covering it now. So if you want to check if your script file has any unused variables or imports, PyFlakes is one of the ways to check it. And after that, it goes on to writing test cases. With Pylint is also, it has covered, but Pylint is more about syntax. In PyChecker, docstrings it has given docstring, doctest. Docstrings, basically by docstring, it means this. We're seeing this code. We have seen this code. And when we run this code, it gives output like this. Python S1, if we run it, the test cases will run because we have called the test mod of doctest package, and it says 1 of 2 failed. Which one failed? This 0. This one failed, factorial 0, because cumulative product, when we will say this will become.
once again, how it is calling the factorial function, because we have called doctest.test mode.
So when we say doctest or test mode, that is
Automatically run the whole code.
Yes, it will automatically run this code. Test mode, it will check.
Suppose there are number of functions, suppose 5, 6 functions. So it will call all the 6 functions.
Shall I check
Is it going to test all the functions?
Yes. 1 second. Give me a second. Let me do that. Script dot py, and then we open it. And let us define over here def is even. And if we give it n, and then we would have to write test cases, test that would pass. What shall we say? Is even. So we would say is even 10, and
So these greater than or the sign is for
this is Python console, Python shell. See?
Python shell.
Python shell. This is like in docstring, we are basically writing, giving it, if we so this is the prompt. This is basically Python prompt. It indicates that we want to execute this statement, and the output we are expecting is 1. Now is even true, and test that would fail is even 9 true, and test that would pass, test that would pass false, and then we would write return RTN equals to n mod 2, return RTN equals to 0. That is correct, right? So if we have something like this test mode, then we would just simply need to exit the console OneDrive, desktop, dir, Python script. 1 second. Okay. Factorial it checked and is even. So yes, it would check all of them. And we could say verbose. Okay, so it checked for 3. Expect.
1 second, 1 second. File script.py. Okay, line 11. What is this line 11 in? Failed example, factorial 0, exception raised, trying. What is trying is even 10.
This is one of the test
Trying.
casing. Trying is like it's trying to execute this test case. Is even 10, right? True. Okay. Trying is even 9.
Why is it trying?
It says it's trying. It's like the way the author of the doc test. Trying means
Failed is not expected. True.
failed. It will fail, right? 9 is not even, and we are expecting true. It returned false. So failed example, it says, then we is even false. So it shows the report over here. 1 of 2 test cases failed in factorial. 1 of 3 test cases failed in is even. 5 tests in 3 items. 3 passed, 2 failed.
Okay. So this doc test, it provides the
ability to test.
Okay. And the report, it generates the report also.
Yes, it generates a report also.
Can you go back to the code?
Yes.
Yes. So generally we don't define this symbol, no, greater than 3 times.
Yeah, generally we do.
This syntax is only for doc test.
This
correct?
syntax, that is correct. This is the way doctest wants you to write test cases.
Okay. Okay. Okay, first, because you have written the codes, so these are just comments, correct? So
Not comments,
inside
this is
comments,
multi-line string. Multi-line
yeah,
string.
multi-line strings or comments, I usually say. So in between, we are providing the Python code by greater than 3 times. Okay. Okay. Mm-hmm.
Hmm.
Even okay. Share this code with me, no?
Okay.
Yes, move on to the next. Then just share this with me. Okay.
Okay.
Code and the output also.
Output also. Okay. You can, I'd give this link to you in chat. It does not have both of them, the new code that we used, but I'd also append that code. Like if what if
Yeah, okay.
that's okay, right? But over
Yeah.
here, if you want to, with doc test, I have shared. And then this one is a bit tricky because it follows TDD approach, writing unit tests, where you write tests that are supposed to fail, and then you then you write code to pass the test. So factorial function.
Negative testing.
Negative test.
Negative testing, we do know.
I am not
Is it
sure.
negative testing?
Negative testing means that we are trying to raise
Check
an
the yeah.
check. It's both. It's negative and positive both.
Okay.
But this requires a bit of coding, like such as you have factorial. We have defined a class called factorial test,
Factorial test.
and then we inherited factorial test inherits unit test use case. Then it has, if this class inherits this, I would need to think, what if we were to have two functions here? What would happen then? How would we rewrite this code? Test factorial.
Let's check this code to us. So we have a class factorial test, and inside that we have 3 functions. Test factorial, test 0, and test negative. Okay, we have assert equal. Assert equal. Okay, and raises. These are inbuilt function.
This function comes with the unit test package, and np is your numpy. Numpy also has a module called testing, and from that module we are using assert equal function. All these are defined over here. 1 second, I'd scroll up if you ask me to, but the testing functions are available like this. We use these three in this piece of code, and otherwise this list is not exhaustive, but numpy's testing module also offers other kind of functions where we have assert equal, assert approx equal, assert array equal, assert array less, assert raises, assert warns, assert string equal.
Okay.
I'd share this link also. 1 second. I'd explain a little bit one by one. 3 functions are there. Hope it wouldn't take too much time. Test factorial is basically we are given, I don't think we need to name it, or if there is at all any naming convention. We have this function, and over here we call this assert function. So this is supposed to come out to be true. If this does not come out to be true, then we would have a failure. And For factorial 3, it would give you cumulative product, and 1 times 1 is 1, 2 into 1 is 2, 3 into 2 is 6. So this we are asserting. Test factorial passes. I think test factorial passes because we don't see it over here. Where we see the error is this test 0. Test 0 assert equal no. If n equals to 0, we had defined return 1. So factorial of 0 would return 1, and we would get...
One second, like now I understand. There's a mismatch in the voice and what you're explaining. I think there's some internet issue.
Okay.
Hello?
Yeah. Am I audible?
Yes, now, because in between you were explaining, the time.
So
Not
assert,
much.
you have 1 second, let me check if I am not wrong.
So self.assert equal and numpy, we are using two the function is same.
Assertion error. Assert is like a statement in Python which tells you that how do we understand, we want to assert something that if this condition fails,
Claiming we claim. Correct.
yeah, we say that if only proceed if this is true. So if 1 is equal to 1, then there will be no error. In pure Python, assert is like this. Assert certain words like this. But if we have other things, we are asserting, we are saying that this test module, this test class, that assert, ask the code to return you 6. If it does not return you 6, go for failure. Now test 0 is one of the class where we will check the factorial for 0, and we are asserting that this should come as 1. If it does not come as 1, return failure. Now test negative is, we do not have a factorial function defined for negative test, so we raise an error. Assert raises index error, but okay, so it does not raises, and it will throw it. So this one failed. Do you see that? This one failed. Why? Because we were asserting that we should get index error. Did we get index error? No, we got value error. Don't be so negative. We got value error, and if we had got index error, this would have been handled. So even if you are expecting an error, that has to match with what you are writing in the code. If n is less than 0, we are raising value error. Over here, it's written index error. So test case fails. Got it?
Yeah, I have to check it after the call code.
So speaking of NumPy, have I been able to explain NumPy, been able to introduce you to NumPy? Is it okay? Would you be comfortable if some problem is given to you and you have to refer to the documentation? Would you be able to write some piece of code yourself?
Currently?
Not currently, by referring to the internet. Basically what happens is, if you are introduced to a package, you do not entirely get everything out of it. So if you are given a small problem, and you can refer to the internet, you can refer to the books, you have the rough idea of how your NumPy works, you should be able to do that. It is my belief, but I want to check with you if you have that confidence in you right now after these two
I think
sessions.
I have not covered or explored all NumPy and pandas. See, this is the first time
So
I'm
NumPy,
seeing the
yeah.
doc test and these things. So now I know how to, work on this testing and things.
Yeah.
So
So
initially I had no idea.
okay.
I think day by day, if I learn or explore this,
Okay.
so that's my short-term goal. You can say for 1 month or 2 months. I want to explore each and every you can say concepts of NumPy.
So the thing that we discussed today, this unit test and doc test, these are Python packages just like NumPy, and they do not have anything to do with NumPy except that if you want to test your code that is using NumPy, you can either use doc test, like defining multi-line strings, or you can use unit test, in which you have to write a class. And I think that you would obviously say that this is easier, and to begin with, this should give you a rough good idea of if the project size is small, we can go with this and there's not too much complication. So NumPy is roughly, we have, if we want, I can take one more session on NumPy, but I would have to one more session. Do you want one more session of NumPy, or we can proceed with pandas next time, tomorrow?
What I'm saying, like today, we worked on doc test and this. What was the other one?
Unit test.
Unit test.
Yes.
So these are the new libraries in Python. Okay.
Yes.
So likewise, I want to cover other areas of Python.
Okay.
Okay. So first, I'll just go through some blocks for NumPy. I know there are some arithmetic operations, all the functions we have for NumPy. Okay,
Yes,
and
yes.
those things we use inside some code.
Yes,
Python
inside some code.
Yeah.
Like this one you're seeing on the screen.
If we want to calculate something, then only we use. So yeah, I want to cover the whole Python actually. So I think by this weekend I will try to cover the NumPy and pandas. Okay, because I don't have good knowledge on the self also. Like why